Mini lesson 4B, 3D figures. The table below has various figures with their lateral surface area formulas, their total surface area formulas, their volume formulas, and their nets laid out in a two-dimensional space. We have prisms, cylinders, pyramids, cones, and spheres. Dimension change consequences. Will you change the dimensions by a specific scale factor? Your new perimeter will just be times that scale factor. However, if you find a new area, surface area, or volume, you'll need to do something further. Let's fill in the ones with the perimeters first. So if the scale factor is 1/2, your new perimeter would be 1/2 times the perimeter. If the scale factor is 3/2, it would be 3/2 times the perimeter. If the scale factor is 2, it's going to be 2 times that perimeter. If the scale factor is 3, it's going to be 3 times the perimeter. Whatever your scale factor is, D, the new perimeter will be that number times your original perimeter. Now, to find the new area or surface area, you're going to square that scale factor. So it'd be 1/2 squared times your surface area. Your new surface area would be 1/4 times the surface area. For the next one, you would square the 3/2 to get 9/4 times your original area. And then for a scale factor of 2, we'll square that to get 4 times your original area or surface area. Basically, whatever your scale factor is, you're going to square it and then multiply by that original area. For volume, this time we're going to cube the scale factor. With the scale factor of 1/2, it would now be 1/8 of that original volume. For 3/2, that would be 27/8 times the original volume. And then if the scale factor is 2, it would be 8 times the original volume. Basically, to change the volumes with the scale factor, you're going to cube that scale factor and then multiply by the volume. One-dimensional, two-dimensional, three-dimensional. On this page, we have the 5 Platonic solids. They're 3D figures with congruent regular polygons. There is only 5 of them. We have the tetrahedron, which is a equilateral triangular pyramid. It has 4 faces, 4 vertices, and 6 edges. And then we have our total surface area and volume formulas. Our next Platonic solid is the hexahedron, which is also known as a cube. 6 faces, 8 vertices, and 12 edges. We have the octahedron, also known as a D8, with 8 faces, 6 vertices, and 12 edges. We have the duohecahedron, which is a D12, 12 faces, 20 vertices, and 30 edges. And then lastly, we have the icosahedron, a D20, 20 faces, 12 vertices, and 30 edges. For Cavalieri's principle, if two solids have the same height and if the areas of their cross sections at every level are equal, then the two solids have the same volume. All three of these three-dimensional figures will have the same volume, even though some of them are curved in different ways, because they have the same length and width for their cross sections. Let's look at some application problems. Joe wants to paint the rectangular walls of his 12 feet by 16 feet bedroom. The height from the floor to the ceiling is 10 feet. Joe wants to paint the four walls with 2 coats of paint and the ceiling with 3 coats of paint. If a gallon of paint covers between 350 and 400 square feet for 1 coat, and each gallon of paint costs $37.87 including tax, how much money will Joe need to spend on paint? The first thing we want to do is draw out a floor plan. We'll say this is the ceiling, and then we have our 4 walls. And then Joe's not going to paint the carpet, so we're going to leave that out of our picture. Okay, so the floor to the ceiling is 10 feet. We have 12 feet by 16 feet. From here, we could calculate the areas. The area of the ceiling would be 12 times 16, 192 square feet. Okay, for this wall, it's 12 times 10, 120 square feet. This one's 160 square feet, 120 square feet, and then 160 square feet. All right, so the surface area of the ceiling is 192 square feet. The surface area of the walls, you'll add these 4 numbers together. $560 square feet. Next, we want to divide the surface area of the walls by the gallons for 2 coats for the walls and 3 coats for the ceiling. We divide by 400 and 350 to get a range. We divide that by 400. We get, let's see, 1,120 divided by 400 is 2.82, and then we'll divide again by 350. .2, and then we'll divide the ceiling ones. 576 divided by 400, 1.44 to 576 divided by 350 is 1.65. We'll round the first one to 3 gallons, and then the second one, we'll go ahead and round it to 2 gallons. The cost for the paint would be 3 plus 2 times that 3787. So it's going to be 5 times 37.87. $189.35. Now, depending on how large their windows and doors are, they may get by with one less gallon of paint. Toby wants to find the volume of plastic needed to print a replica of a solid toy soldier figure. He fills a rectangular container 8 centimeters long, 6 centimeters wide, and 10 centimeters high with a water to a depth of 4 centimeters. Toby totally submerges the toy soldier in the water. The height of the water with the submerged toy soldier is 7.1 centimeters. What is the approximate volume in cubic centimeters of the toy soldier? First, let's draw a picture of this rectangular prism. The height is 10 centimeters, and the water is to a height of 4 centimeters. We have lengths and widths of 8 centimeters and 6 centimeters. Let's find the volume when we use a height of 4 centimeters. The volume of the water would be 4 times 8 times 6. That's 192 cubic centimeters. And then the volume with the water and the soldier would be, instead of 4, we're going to put 7.1. Let's see, 7.1 times 8 times 6, 340.8. To get just the soldier by itself, we would subtract these two. And that would give you 148.8 cubic centimeters. A container is 1/8 full of water. After 10 cups of water added, the container is 3/4 full. What is the volume of the container in cups? So we're going to say that 10 cups is equal to 3/4 minus 1/8 of the container. All right, let's find the differences of these. We have 6 minus 1, it's 5 over 8. So 5 over 8 is 10 cups, and we want to find the number of cups for one whole. Let me rewrite that. From here, we could cross multiply and solve this proportion. 5/8 C equals 10. Multiply by the reciprocal. 10 divided by 5 is 2, and 2 times 8 is 16. After a snowstorm, city workers removed an estimated 12,000 cubic meters of snow from downtown. If this snow were spread in an even layer over an empty lot with dimensions 62 meters by 85 meters, about how many meters deep would the layer of snow be? The volume of a rectangular prism is length times width times height. It wants to know how many deep, which would be the height. And they give you the length and the width, and they give you the volume. Let's plug those in and solve. "62 times 85 is 5,270. Divide each side by 5,270. And we get about 2.28. In order to clean his 50-gallon aquarium, Keith must remove half of the water. The aquarium measures 36 inches long, 18 inches wide, and 19 inches deep. The aquarium is currently completely full. What volume of water in cubic inches must Keith remove? So he's going to remove 25 gallons. And we want to know how many cubic inches that is. It says that the aquarium is completely full, so we'll find the volume using those three numbers. 36 times 18 times 19. And then if we're removing half of that, we're going to divide this answer by 2. So that'd be 1,156 cubic inches.